Hosted coding agents are getting very close to the thing every platform team keeps rebuilding: a loop that reads a repo, runs commands, changes files, and remembers what happened. On Fluid Coding and AI, we are comparing the self-managed version with Gemini Managed Agents, because the real question is where the agent loop should live. The tempting story is simple. One API call starts a managed coding agent, and suddenly you do not need to build the orchestration layer. That is partly true. Google now exposes managed agents that can reason, use tools, execute code, browse the web, manage files, and work inside an isolated Linux environment. But a dev support agent is not just a clever loop. It is credentials, repo policy, cost limits, review gates, traces, retries, and a decision about who owns the runtime boundary. So let us build the same target agent both ways. It watches a repository, triages issues, and failing continuous integration, reproduces problems in a sandbox, proposes a minimal patch, runs the relevant tests, and either opens a pull request or leaves a draft report. That sounds straightforward until you add the real requirements. It needs to read logs, inspect files, search dependency changes, edit code, stop before risky actions, and leave an audit trail that a human reviewer can trust. The lightweight self-managed version starts with boring infrastructure. A GitHub webhook, scheduled job, or manual command creates one queued task. A worker clones the repo into a controlled workspace like Docker, a dev container, a micro VM, or a CI runner. The outer loop is deterministic. It records status, commit shay, token budget, model calls, tool calls, logs, retries, and stopping conditions. Inside that boundary, the model can request tools, receive real command output, and continue until the task is done or stopped. The benefit is control. Your team owns the sandbox image, secret scoping, egress rules, logging schema, retry policy, model routing, approval gates, and cleanup. You can keep private source inside your own infrastructure. You can run a small model for triage and a stronger model only when the patch is difficult. The cost is that you now own the hard parts too: hung tools, masked credentials, crash recovery, trace viewers, timeouts, billing caps, and the evaluation harness that tells you whether the agent is improving or just getting louder. Gemini Managed Agents moves a large piece of that stack into Google's runtime. In the Gemini API, the default managed agent is the anti-gravity agent, powered by Gemini 3.5 Flash and exposed through the Interactions API and Google AI Studio. The documented preview agent can run in a remote Ubuntu-based environment with code execution, Google search, URL context, and file system access. A first request can provision a fresh sandbox, and later requests can reuse the returned environment ID, so files, packages, and state persist across interactions. The important feature is not just tool calling, it is hosted state. There are different layers here. The environment ID refers to a sandbox with files, installed packages, and working state. The previous interaction ID continues server-side conversation history. In the enterprise platform, memory bank is a separate long-term memory system with identity scope, revisions, time-to-live controls, and search. Those are not interchangeable. For repo maintenance, confusing sandbox state, chat history, memory, and branch state is how an agent becomes impossible to debug. Managed Agents also has an important packaging story. Google's custom agent examples start from the anti-gravity base agent, then add system instructions, environment sources, repositories, and skills. The examples use agent instruction files and skill files to package behavior. That matters because a repo maintenance agent needs conventions, not just tools. Always inspect the failing tests first. Prefer minimal diffs, never edit generated files unless instructed. Always report commands run and risks left unresolved. Skills are becoming a kind of operating manual for agents. The portability question is whether your team's operating manual can move between. There is one detail we cannot blur. The public Gemini API surface and the enterprise agent platform surface do not have the same defaults. In the public managed agent docs, environments have unrestricted outbound network access by default, with an allow list available to restrict egress. In the Enterprise Agent Platform docs, the sandbox is described as isolated by default, with connectivity and credentials explicitly configured. That is not a contradiction to hand-wave away, it is a surface-specific difference, and it changes how you think about private repos, dependency downloads, package registries, and policy review. The model evidence is strong, but it has to be scoped correctly. Google's first-party materials report Gemini 35 Flash at 76.2% on Terminal Bench 2.1, 55.1% on SWE. Bench Pro Public, 83.6% on MCP Atlas, and 78.4% on OS World Verified. Those scores support the idea that the underlying model and harness are serious for agentic coding and tool use. They do not prove that a managed agent will safely merge maintenance pull requests in your organization. Benchmarks measure capability. Governance is a different. Take a dependency update assistant. In the self-managed design, Dependabot or a scheduled job triggers your worker. The worker uses the exact CI image, reads the changelog, runs whitelisted tests, patches the repo, and opens a pull request only after your policy allows it. In the managed design, a remote anti-gravity environment can clone or receive the repo, install dependencies, search release notes, patch files, and save a report or diff. Both can solve the coding problem. The difference is where source access, network access, credentials, and pull request authority are enforced. Managed does not mean ungoverned. Google says one managed agent interaction can typically consume from 100,000 to 3 million tokens, and pricing follows model tokens and tool usage. Environment compute is not billed during preview, but long loops still need budgets. Credentials also stay dangerous. Google warns that agents can use credentials they can access, and the Enterprise pre-GA docs warn against proprietary, sensitive, or confidential data in that surface. So the production question stays familiar. Least privilege, short-lived credentials, narrow network access, human review, and a hard stop. Here is the practical verdict. Use a self-managed loop when governance is the hard part. Sensitive repositories, deterministic CI images, strict egress, custom logs, model routing, cost accounting, and approval gates before writes. Use Gemini Managed Agents when the painful part is the hosted workbench, sandbox setup, code execution, file persistence, web research, tool loops, and reusable agent skills. For most serious repo maintenance agents, the boring hybrid is probably right. Keep a self-managed controller for policy, queue, secrets, and pull request creation. Delegate bounded sandbox work to Gemini when the runtime boundary is acceptable. If you are building agents that touch real repositories, the runtime boundary is the architecture. Like the video if this comparison helped, and subscribe to Fluid Coding and AI for more practical breakdowns of AI coding systems.